Hi everyone, welcome to Despot MBA Prep. In this session, we will look into data interpretation, the types of data interpretation, what are the various calculation techniques that can be used while solving data interpretation problems. So in case you haven't subscribed at our YouTube channel, subscribe it and press the bell icon so that you will never miss the updates. So let's move on to the basic terms that we use in data interpretation. The first one is average. So most of you are aware of these basic terms, but let me repeat them once again. We know average is known as, we'll define it as the sum of the terms by total number of terms. Understood? And we have percentages. Percentage, the value obtained by the value obtained by the base value into 100. And we have percentage increase. This is for percentage increase. We have the increase, that is the difference by the base value into 100, whereas for percentage decrease it will be decreased by base value into 100. Same goes with percentage change. Percentage change is calculated as the difference between the values by the base value or the original value into 100. See here, the table shows the sales of two companies, right, over 4 years, right, from 1999 to 2002. So the sales are in $1 million, right? Let's say 25 means $25 million, 45 million dollars, something like that. So if I ask you to find out of total sales in 2000, what percentage of sales belongs to the company A? See here, out of total sales in 2000, what percentage of sales belongs to company A? So in 2000, if you observe, what is the total sales? Total sales of company A is 30 and total sales of company B is $45 million, right? So total sales is 45 plus 30, that is 75. But he asked to find out the percentage of sales that belongs to A. So what is the number of sales that belongs to A? 30, right? So 30 is the number of sales belongs to A. So 30 by 75 into 100. This will be equal to 40%. So this is the total sales which belong to company A. If I ask you to find out the percentage increase of company B between the years 1999 and 2001, then what would you do? How can we calculate that? See here, total sales in 1999 of company A is 50, right? Total sales in 2001 is 60, and we are asked to find out the percentage increase in sales. So find the difference. 60 minus 50, that is equal to 10 by the base value. What is the base value? The original value 50, right? This is the initial value. So 10 by 50 into 100, this will be equal to 20%. And what if I asked you to find out the percentage decrease in the sales of company B in the year 2002? How do you calculate? See, if I ask you to find out the percentage decrease of some year, then you must compare the value with the previous year's value. Understood? I didn't mention here to calculate the difference between calculate the percentage decrease between any 2 years, right? Like 2002 and 2002 and 1999, like that. So I didn't mention here like that. So you must take the previous year as a reference point. So the sales of company B in 2002 is 50, right? And the sales in 2001 is 60. So 50 and 60. So calculate the difference. It's 10 by the initial value. So this comes first. So 10 by 60 into 100. This is equal to 16.67%. Right? So now calculate the difference between percentage changes in sales of both company B and A in 2001. So to calculate the difference between percentage changes, we must calculate the individual percentage changes in 2001. As I told you previously, in order to calculate percentage change of a particular year, you must take the previous year's value as a reference point. So percentage change in sales of company B in 2001 is 60 minus 45 by the base value, that is 45, into 100. This will be equal to 33.33%. Consider company A, this will be 40 minus 30 by the initial value, which is 30, into 100. This will be equal to again 33.33%. So we are asked to find the difference between these two percentage changes. This will be equal to 0, right? So this one and this one. And we have some more important terms like inflation, depreciation, deflation, appreciation, and the compounded annual growth rate as well as the average annual growth rate. So we will discuss one by one after while solving the questions, right? So at that time we will discuss. Let's move on to first type of DI, that is line graph. But what is meant by line graph? We all are aware of that. So in a line graph we have coordinate plane where we have two axes, the x-axis and y-axis, and the information is given for both the axes and it will be compared, something like this. This is the x-axis, we know this is the y-axis, and the information is compared between these two. Let's solve this. This is a CAT 2003 question. Let's solve this first. In the upcoming slides we will come across the bar graphs, pie charts, the mixed graphs. So we have taken all these from different exams, one from CAT, one from ZAT, one from IFT, and one from Tissnet and SNAP. That too we have collected only the basic level models from those exams, just to make you understand the difference between each and every graph and also how to interpret these graphs. Because CAT doesn't test you your calculations, it tests you your logic. So heavy calculation parts do not appear in CAT. They may appear in IBPS, PO or SSC or RRB, something those kind of government exams. But in CAT, in ZAT, the data interpretation problems, the graphs that are given only tests your logic, not much calculation, right? So answer the questions on the basis of the information given below. The length of an infant is one of the measures of his or her development in the early stages of his life. The figure below shows the growth chart of 4 infants in the first 5 months of life, right? So this is the month right from 0 to 5, and this is the length of the infants, right? 45, 50, which are expressed in centimeters, and Sita is expressed in this manner, and Geeta in this, Ram in this shape, and Shyam in this manner, right? So you can have a look into this respective graphs, individual graphs. So what is our first question? After which month did Sita's rate of growth start to decline? So where is Sita's graph here? This one, right? This circular type at the center. See here, observe, if we carefully look into this, the growth rate of Sita in the first and the second months is slightly high. This is the first one and this is the second one, slightly high, and it went to maximum in the third month. But from third to fourth, right, that is from the fourth month, it didn't achieve the considerable growth rate as previous, right? So the growth rate comes down in respect of the second to third month, right? So the decline rate starts from third month. If the growth rate had been the same, then the graph would have been like this, right? But the graph is like this. Since the graph is like this, it started declining. Hence, after third month, Sita's rate of growth start to decline, right? Let's move to the second one. Who grew at the fastest rate in the first 2 months of life? So among these four, who has the fastest growth rate in the first 2 months. So if you observe for Sita, after 2 months it has become around 52 centimeters, right? 52 centimeters. Whereas if we move on to Gita's graph is almost close to 58 centimeters. If we move on to Ram, it's close to 55 centimeters, and if we move to Shyam, it's almost 56 centimeters. So by observation we can say that among all the infants, Geeta is the only child whose length was minimum at initial, but after 2 months her length is maximum. Hence her growth is maximum among all these infants. The rate of growth during the 3rd month was the lowest for. So we are asked to find out the growth rate during the 3rd month. Okay. So during the 3rd month, if we observe the height of Sita, it has increased from 51 to almost 54, right? This is for Sita. If we observe for Geeta, during 3rd month, it's increased from 56 to almost 57, and the height of Ram has been increased from 55 to almost 58, right? And what about Shyam? Shyam's height has been increased from 53 to 55. So if we observe all these 4 infants during the 3rd month of their growth, the rate of growth is lowest for Geeta. So Geeta is the correct answer. And moving on to the 4th question, among the 4 infants, who grew the least in the first 5 months of life? So in order to calculate the growth after 5 months, we can simply calculate by taking the difference of the final length and the initial length, right? Final height and initial height. If we look into Sita's, then this is initial value is 50 and the final value is 60, right? So for Sita, it's the final value is around 58 and the initial value is 50. So this difference is 8. And for Geeta, the final value is touching 62 and the initial value is 49. So this is almost 49 and the difference is 13. And for Ram, the initial value is 51 whereas the final value is around 61. So 61 minus 51, that is equal to 10. And moving on to Shyam, the final value of Shyam is almost 58 and the initial value is 53. So the difference is 5. So who has the least growth in the first 5 months? It's Shyam. Let's move on to the second type, that is the tables, the data tables. So this is a frequently asked question in almost every MBA entrance exam. However, the difficulty level varies, as we know. So this is a ZAT 2010 question. So based on the information given below, the retail prices of flowers, consumer expenditure on flowers and sales of flowers for the calendar year 2009 in a small town with a population of 70,000 is summarized in this table. Okay, so here we have month price of roses per dozen and average consumer expenditure on roses and carnations and the total consumer expenditure in dozens. So let's move on to the first question. Compared to January, the total expenditure on carnations in March is. So this is January, this is March, and we know the total population of the town is 70,000 and the average consumer expenditure on roses and carnations both in January is 47.4 rupees. So 47.4 into the total population, which is 70,000. So this is the total expenditure on both roses and carnations. And we know the total consumer expenditure on roses in January is this much. So just subtract these two to get the total expenditure on only carnations. If we subtract this and this will be equal to the total expenditure on carnations, which is 2181,084. Let's move on to March. In March, the average consumer expenditure on both carnations and roses is 49.5 and the population is 70,000. So this will be around 3-4. This is the total expenditure on both carnations and on roses in March. And we know the total consumer expenditure on only roses. So subtract these two to get the value of only carnations. So minus 1137915. This will be equal to 2327085. Right? This is the expenditure on only carnations, and we are asked to find out the total expenditure on carnations in March compared to January. Okay, so this is expenditure on carnations in March, this is in January, so subtract these two now. If we subtract, this will be equal to 146001, and we are asked to find out the percentage change. So percentage change means we have to add the base value in the denominator. So what is the base value here? This one. So divided by 2181,084 into 100, and after calculating the value we will get 6.69% increase, right? So option C is the answer. Let's move on to the second question. Compared to January, the sales of roses in July increased, decreased, or did not change? Okay, so in order to calculate the sales of roses, we must first find out the number of roses sold, right? And the number of roses sold in January as well as the number of roses sold in July. First calculate the value in January. We know the total expenditure on roses is 1136919 in January. We also know the price of roses per dozen is 99 rupees. So 99 divided by 99. So this will give us the number of dozens sold. So 11484 dozens. Similarly, in July, the total expenditure on roses is 1188432 divided by the price of roses per dozen is 144. This will be equal to 8253 dozens. But we are asked to find out the percentage change in the sales, right? So take the difference, 11484 minus 8253 by the initial value, which is 11484 into 100. So calculate this, we will get 28.13%. Is it an increase or decrease? See, from 11,484 in January, it came to 8,253. So it's definitely decrease. So 28.13 decrease in the value. Now the next type of DI is bar graph. Let's solve this question to have a clear understanding on bar graphs. This is the question that appeared in SNAP 2012. So let's move on to this question. So the graph shows the demand and production statistics of 5 TV companies. If we observe this gray color, this is the demand, and this light color is the production value, right? And company A, company B, company C, D and D, 5 television companies. So the first question is, what is the difference between the average demand and the average production of the 5 companies taken together? So what is the total demand? Total demand of the first company is 3000 and the second one is 600. The demand of the third company is 2500. The fourth one is 1200 and the fifth one is 3300. So total demand. So add all these values, we will get 10600 units. This is the total demand of all the companies. What about the total production here? The total production is 1500 for first company, 1800 for the second, 1000, 2700 and 2200 respectively for all the 5 companies, and add them, we will get total production as 9200 units. Now we are asked to find out the difference between average demand and average production, not the difference between the actual demand and production. So we must calculate, we know the average, we know the total demand of all the companies, but we must calculate the average demand of this. How can we calculate the average demand? We have total demand by we have total number of companies, that are 5, so this will be 2120. This is the average demand of the 5 companies. What about average production? We have total production 9200 and the average means by the total divided by total companies, this will be equal to 1840. So this is the average production, average demand, and this is the average production. So calculate the difference. 2120 minus 1840, this will be equal to 280. So 280 is the answer. Let's move on to the second one, that the production of the company D is how many times of the production of company A. So here, what is the production of company D? Production is 2700, right? Production is 2700 for company D, and this is how many times of the production of company A. What is the production of company A? It's 1500, right? So 2700 by 1500, this will be equal to 1.8. So 1.8 times of that of company A, right? So the next type is pie charts. So it's basically a circular representation of data, and in this circular representation, the total angle of this representation is 360 degrees. And in pie charts, we know that each and everything will be the sector, right? So in order to calculate a particular sector, the value of a particular sector, then we must take the angle of that. So the angle of sector will be theta by 360 into pi r square. This is one thing, and we can also use this one, theta by 360 into total value. So where theta is the angle. So in order to calculate the value of any sector, so whether it's big or small, we can use these values, right? So let's solve this question now. So refer to the following pie chart and answer the questions that follow. The chart shows the number of units produced in degrees by company X of India for the quarter July to September 2010. This came in IIFT of previous years, I think IIFT 2010. See, by how many units does the number of units produced in Bihar exceed the number of units produced in Madhya Pradesh if the total production in the quarter is 72,000 units? Okay. See, we are asked to find out the difference between the value of Bihar and that of MP. So what is the value of Bihar here? 45. This is the sector in which Bihar is represented, and the sector in which MP is represented is this one, 32.4, right? So what is the difference in the angle of Bihar and Madhya Pradesh? 45 minus 32.4 degrees, right? 45 degrees minus 32.4 degrees, that is equal to 12.6 degrees. So if this is 12.6 degrees, and we all know the total angle of this pie chart is 360 degrees. So 360 degrees is the total angle, and the total number of units, the total production is 72,000 units. So if 360 degrees is equal to 72,000 units, then how much is 12.6 degrees equal to? So find out, cross multiply and find out this. So this will be equal to 2520. So the total if the total production is 7200 units, by 2520 units the production of Bihar exceed the production of Madhya Pradesh, right? So the next type is mixed graph. This is a most important model and a common model in IFT, in CAT, in ZAT, in Tissnet as well. So how can we expect, what can we expect in mixed graphs? It is mixed because we are represented with two or more different graphs. That can be a combination of pie chart and bar graph, or a line graph, bar graph and a pie chart as well, or a table, a pie chart and a line graph. So it's a combination of two or more than two graphs, right? So let's solve this. This appeared in Tissnet. Study the following graph and table carefully and answer the questions given below them. Okay, so this is see here in this mixed graph, table is given and line chart is given, right? Let's move on to the first question. What was the approximate average of obese men, obese women and obese children in 2007? So total number of men, women and children in the state over the years. Okay, so total number of men, women and children of all the years respectively. And in the chart, in the line chart, we have the percentage of obese men, women and children. Okay, here we have percentage, here we have total number. Understood? And obese men are represented with this color, obese women with this color, and obese children with light green color, right? So the approximate average of obese men, obese women and obese children in 2007. So where is 2007 here? Here it is. And we know total men in 2007 are 66,000, right? 66,000. And in 2007, in this case, in line graph, the percentage of obese men is how much? It's almost 30, yeah, it's 35%, right? So 35 by 100. So out of the total 7, 35% of the total men are obese. So we are asked to find out the average obese men. So in order to calculate average obese men, we must first calculate the total number of obese men. So this will be equal to 23100. So the total obese men in 2007 are 23,100. What about the total women who are obese? Well, total women in 2007 are 54,000, right? So 54,000, and the percentage of women who are obese in 2007 is 25%. So 25 by 100, this will be equal to 13500. So 13,500 women are obese in 2007. What about children? Total number of children in 2007 are 16,000. Let me write it here, 16,000, and the percentage of children who are obese in 2007 is almost 12%, right? So it's almost 12.5%. So this will be equal to 2000. Okay, so we know the total obese women, obese men, obese women and obese children. Now we are asked to find out the average of that. So calculate average. So let me write it here. Total obese men are 00 plus children who are obese are 2000 by 3. So this will be equal to 12867 approximately. So option C is the correct answer. Let's move on to next question. The number of obese men in the year 2009 was what percent of the men not suffering from obesity in the same year? Okay, so the number of obese men, the percentage of obese men in 2009, what is the percent? Percent is almost 36 point something, right? So the percent is almost here 37.5%, right? So 37.5% of men in 2009 are suffering from obesity, whereas the total number of men in 2009 are 78,000. So 37.5% of 78,000 is equal to 29,250. right? And persons who are not suffering from obesity are, so how can we calculate persons who are not suffering from obesity? It's the total number minus the persons who are suffering from obesity. So 78,000 minus 29,250, this will be equal to 48,750. So person not suffering from obesity, and these are the persons who are suffering from obesity. But we are asked to find the percentage, right? Percent of what? Percent of men not suffering from obesity in the same year. So just calculate the percentage here. 29250 by 48750 into 100. This will be equal to 60%. So option B is the answer. So these are the basic problems of different types of DI. So these are basic models that are appeared in previous years IIFT, ZAT, CAT and SNAP Tissnet exams. In the upcoming videos we will deal with them. We'll deal with these problems separately, separate bar graphs, line graphs, mixed, and the pie charts. Separately we will solve different harder, tougher level problems. So in case you haven't subscribed, you can subscribe our YouTube channel so that you won't miss any update. You can also join our Telegram group for more updates. Keep revising. Thank you very much and all the very best.